All right, so we're going to spend a couple of days. Let's get started, guys. A couple of days talking about limits. We've worked kind of in a roundabout way with the ideas that we're going to talk about. We're just going to get a little more, talk about them in a little more detail. So what I'm going to do is the packet that I gave you. This is going to be essentially your notes for limits. It does a pretty good job of explaining, and it lays it out really nicely. So that's what we're going to use. So let me grab this first part. Got to find my camera. Capture, there we go. So let's look at this first part. So this is the top of your packet. So we're looking at this graph of x cubed minus 8 over x minus 2. So this is a rational function. We talked about rational functions and how we graph them. Now, because 2 is a factor of the numerator and denominator, we have a hole in the graph at x equals 2. When we have a factor of the numerator and the denominator, we have a hole in the graph. So when we graph this at x equals 2, we don't have anything on our graph. With limits, what we're looking at is we want to know what happens when x gets close to 2. So what values, what function values, what y values do I get when x gets close to 2? So what we're going to do for this first part is, in this chart, they want us to plug in some different values of x into this function and figure out what we get for our function value, what we get for y. So I've done this. We're going to fill in this chart. When x equals 1.75, if we plug that in, we get f of x equals 10.563. And again, what we're interested in is what happens to this function as x gets close to 2. At x equals 2, it's undefined, but what happens when x gets close to 2? At x equals 1.9, we get 11.41 if we plug that in. If we plug in 1.99, we get 11.94. If we plug in 1.999, getting closer to 12, we get x equals 11.994. So what is our function getting close to? 12. At x equals 2, our function does not exist. We write DNE, does not exist.
So I just say
NA, you could say NA, yeah. Now we're on the other side. We're looking at what happens when x is close from the other side. We went this way first. Now we're going to go this way. And I'm going to go backwards because I want to get closer and closer and closer to 2. So we'll go this way on the chart. So at 2.25, I get, when x equals 2.25, I get 13.563. If we plug in 2.1, I get 12.61. If I plug in 2.01, I get 12.060. And 2.001, I get 12.006. So we see as we're going this direction, as we get closer and closer to x equals 2, my function value gets close to 12. And as I go this direction, as x gets closer and closer to 2, f of x gets closer and closer to 12. So what we say is, we figured out that x gets close to 12, and we say that the limit of f of x as x approaches 2 is 12. And we write it this way. The limit of f of x as x approaches 2 is 12, or we write the limit as x approaches 2 and we write our function, and that equals 12. Now, one important thing to remember here is that f of 2 does not exist. So we're not necessarily interested in what the function value is at x equals 2. What we're interested in is what it gets close to. So the limit can exist. We can have a limit even when the function doesn't exist. So in this case, f of 2 does not exist, but the limit is 12. And as it says on the sheet there, our informal definition of a limit is what happens to y as x gets close to a certain number. And in order for the limit to exist, it has the limit has to be the same approaching from the left and approaching from the right. Yeah, Jesse. Not necessarily. It depends on the function. It can be any kind of number. In this case, it was a nice whole number, but it's not always a nice whole number. Just depends on what the function is doing. So if you look at the next portion of your sheet here, let me grab that. So again, what we're interested in is what happens to the function as we get close to a certain number. And in order for our limit to exist, that limit has to be the same coming from the right and the left. When we come from the right, we say that we're interested in the limit as x approaches some number, c, and the little minus sign tells us we're coming from the left-hand side. We're coming from the negative side of the number line. And if we're coming from the right-hand side, we write a little plus by our number telling us that we're coming from the positive side of our number line. In order for a limit to exist, the limit has to be the same coming from the right-hand side and from the left-hand side. So any questions about that idea? Okay. So in this first section with limits, we're just looking at this in terms of a graph. What does the graph look like? So let's look at this first example. We'll do several of these examples together, and then the homework is going to look essentially like these. So if we look at the limit as x approaches 1 from the negative side, from the left side, as we get closer and closer to 1, what does this function get closer and closer to? As we're coming up from the left-hand side, what does our function get close to? What is it? 1. Yeah, we're just going and we get closer and closer and closer to 1. So the limit as x approaches 1 from the negative is 1. The limit as x approaches 1 from the positive, so we're coming along this direction. What's that limit? 2. We're just getting closer and closer and closer to 2. What is the function value? What is the function value f of 1? It's 2 because we have a closed dot on 2. So the function equals 2 at x equals 1 because we have a closed dot on 2. What is our limit as x approaches 1? Is it the same coming from the left and the right? It's not the same coming from the left and the right, so my limit does not exist. As we come this way, we get closer and closer to 2. As we come this way, we get closer and closer to 1. So the limit does not exist. It has to be the same for the limit to exist. Now let's look at our next example. As we approach x equals 1 from the negative, so we're coming along here. What does the function get closer and closer to as we get closer and closer to 1? Negative 1. Y equals negative 1 as we come closer and closer here. So as we come from the left, we get a negative 1. As we approach from the positive side, as we come along here, what's our function get closer and closer to? positive 1. We just get closer and closer to this point here. The function, what does the graph tell us the function value at 1 is? 0, right? We have a closed dot at 0. These are open dots. So our function value is 0. What is our limit? Someone said it. Does not exist. Because we get closer and closer to negative 1 here, closer and closer to positive 1 here. So that does not exist. And again, when we're looking at our limits, we don't care what the function value is. We want to know what happens as we get close to that value coming from our two different directions. All right, let's look at a couple more examples from the next page. Let me grab the next page. All right, so let's look at these. You don't have this page? No?
We don't have the absolute value graphs.
Oh, okay. So it just jumps. All right, I see what they did. I was going to do some extras. So why don't we just do a couple of examples since I have them up here. They're not on your packet, so we'll just do a couple of examples from this page, and then we'll go to the next page. So just to practice on doing a couple of these together. Let's look at example 3. Let's look at example 3 and then example 6. So on this one, as x approaches 1 from the negative side, what does our function approach? 1. As we approach it from the positive side, 1. What's our function value at? It's undefined or does not exist because we have an open dot. So our function does not exist at 1 because we have an open dot there. But what's our limit? 1. Our limit's 1 because it's the same coming from the left and the right. Let's look at number 6. As we approach 2 from the left-hand side as we're going along here, what does my function get close to? Infinity. It keeps going up and up and up. And as I go from the right-hand side, what does it get close to? Keeps going down, 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 down. So minus infinity. What is the function value at 2? We have a vertical asymptote. So what's our function value? Does it exist? Our function does not exist at x equals 2. And our limit? As we come from the left, it goes to positive infinity. As we come from the right, it goes to negative infinity. Are those the same? No. So we say it does not exist. So our function doesn't exist and our limit doesn't exist at x equals 2. An asymptote is like a limit, yes. What's that? But our function so it's not like a limit. Our asymptotes tell us where we might have to figure out what the limit is, where we might have something strange going on with the limit. Our asymptote tells us where our function is undefined. because as we get closer and closer to 2 from the left, our function just keeps getting higher and higher and higher. It goes to infinity.
So your limit is the limit of the y factor.
Right. We're looking at the y value. We're interested in the y value as we get close to this, as we get close to that number. Does that make sense? Okay. All right, so our next page is we're looking at limits at infinity. So let's look at that one. I'm going to go to that one. And we'll capture that. So what we're interested in now is what happens as x gets really, really large or x gets really, really small. So in our other examples, we were looking at x approaching a specific value, 1, 2, something like that. Here we're interested in what the function does when x gets really, really large or x gets really, really small. And again, we talked a little bit about this when we did rational functions, when we talked about rational functions. So we write the limit as x approaches positive infinity, which means we're going further and further and further to the right, or as x approaches negative infinity, which means we're going further and further and further and further to the left. It doesn't make any sense. This question says, doesn't really make any sense to talk about approaching infinity from the right or from the left, because the idea of approaching from the right or from the left means we can get on the right-hand side or the left-hand side of infinity and come at it from 2 directions. And if we're at positive infinity, we can't really get further right than positive infinity and come at it from the other direction. So we can't come at infinity from 2 different directions. We're either going further right or further left. So we have 4 possibilities when as x approaches infinity or as x approaches negative infinity. So our first possibility, I'm going to label this one number 1. For our first possibility, the curve just keeps going up forever. So in this case, my curve keeps going up. So as x approaches negative infinity, as I keep going this way to the left, my function just keeps going up and up and up and up and up. We say that the limit as x approaches negative infinity is infinity. Our second possibility, number 2, is that our function just keeps going down forever as we go left or right, as x gets larger and larger or smaller and smaller. It goes down forever. And what I want you to do on this one is change this. They put a little sign here. This should be a positive infinity here. So I want to do that example. So the limit as x approaches positive infinity. As we're going further and further and further and further to the right, my function keeps going down, 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 down. So the limit of this function as x approaches positive infinity is negative infinity. It just keeps going down and down and down and down. Does that make sense to everyone? We're just looking at what the function does as x gets smaller and smaller and smaller. This keeps getting bigger and bigger. Or as x gets bigger and bigger and bigger, this function just keeps getting smaller and smaller and smaller. So we get closer to negative infinity. Our next 2 possibilities are, we talked about these when we worked with rational functions before, is that we have some kind of asymptote. So if we have a horizontal asymptote, as x gets larger and larger and larger, that horizontal asymptote, and this might have been kind of along the lines of what you were thinking of earlier, Travis, is a horizontal asymptote. As as we approach negative infinity, as we go further and further and further this way, the function gets closer and closer and closer to our horizontal asymptote. So our horizontal asymptote is, in fact, the limit of the function. Okay? So as x gets larger and larger and larger, negative, as we go further and further this way, my function gets closer to my asymptote. So the limit as x approaches negative infinity is, and that's on this side, negative 1. And as x approaches positive infinity, as we go further and further this way, it gets closer and closer to this asymptote. So that would be positive 1. So a horizontal asymptote is a limit. Our function eventually gets really, really close to the horizontal asymptote. And this is our number 3 possibility of our 4 possibilities. And our number 4 possibility is that our function levels off, but it oscillates. So this function just keeps oscillating, but the oscillations get smaller and smaller and smaller as we go positive and negative. So here we can think of the x-axis, y equals 0, as our horizontal asymptote. This function just keeps oscillating smaller and smaller and smaller and smaller. It's like a guitar string that you pluck. It vibrates less and less and less and less, and eventually it's going to stand still. That's kind of what this looks like. So as we approach positive infinity and negative infinity, this function is approaching 0. So our function can oscillate around the limit, around the asymptote also. So those are our 4 possibilities of our function as x approaches positive infinity and negative infinity.
Or
A piano string the same way. So let's look at a couple of examples of these. Is that the page you guys have? No? That one? Okay. So let's look at these. Questions before we look at these examples? So these examples bring all of our different limits together. We're looking at as x approaches a specific value and as x approaches positive infinity and negative infinity. So on number 7, as x approaches 1 from the left-hand side, that's what this one is asking us. As x approaches 1 from the left-hand side, what does our function approach? It keeps going down, 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 down. We have a vertical asymptote, so this would be negative infinity. As x approaches 1 from the positive side, as we coming from this side, what does x do, or y do? Keeps going up, 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 up. So what would this limit be? Positive infinity. The limit as x approaches 1, is it the same from the left and the right? No? So it does not exist. What is the function value at 1? Does f have a value at 1? No, does not exist. As x approaches negative infinity, as we go further and further and further this way, what does the function get close to? 1. It gets close to our horizontal asymptote. And as x approaches positive infinity, negative 2. So those are our limits for this function. Let's look at
I don't really get how infinity can be over there.
we're not saying, that, and that's a good question. We're not saying that the value equals infinity. We're saying that it gets closer and closer and closer to infinity. So we're not saying at some value of x, the function equals infinity. We're saying as we get closer and closer and closer to that value, for example here, as x approaches, right, there is no limit. It's undefined. You could say it's undefined. Here it's important to tell us, say what the sign is, because it gets larger and larger and larger negative number. It's a larger and larger and larger negative number. So you could say undefined negative. Just for convenience, we say negative infinity. But we're not saying that it eventually equals some number negative infinity or positive infinity. We're saying it just gets larger and larger and larger and larger and larger. Okay? All right, let's look at number 8. As x approaches 3 from the left side, so we're going along here, what happens to my function? Keeps going up and up and up and up. So we could say positive infinity. As x approaches 3 from the negative side, keeps going up and up and up and up again. We could say infinity. So we could also say, to go along with what Alex asked, we could say the limit does not exist because it goes to positive infinity. The limit as x approaches 3, is it the same from the right and the left? It is the same. So we could say the limit is infinity. And it would not be incorrect to say the limit does not exist. Either one of those is correct. We could say does not exist here. We could say does not exist here. This using infinity kind of helps us keep track. Are we getting bigger in the positive direction or bigger in the negative direction? Function value at 3. Since it has a vertical asymptote, our function value does not exist. And it wouldn't be, here we don't want to say the function value equals infinity because nothing ever equals infinity, so we say does not exist. The limit as x approaches infinity as x approaches negative infinity, as we go to the left, what's our limit? We have a horizontal asymptote and it's at -1. So our limit is -1. And as we go further and further to the right, as we go to positive infinity, our function approaches 0. 0 is our horizontal asymptote. So as we go towards positive infinity, we go towards 0. Our function goes towards 0. All right, let's look at number 9. As x approaches 2 from the negative side, so we're going along here, what happens to my function? Goes to negative infinity. As we go towards 2 from the right-hand side, keeps getting smaller and smaller, so it's also negative infinity. So now let's be careful with this one. The limit as f approaches 2, what's our limit? Is it the same from the right and left? It is, so that would be minus infinity. What's the function value at 2? 1, it tells us, it gives us a dot. So the function value equals 1. And notice on a lot of these, like I said at the beginning, the limit and the function value are not necessarily the same. Here my limit is negative infinity, well my function value is 1. As x approaches infinity, as x approaches negative infinity, what does my function get close to? Gets close to 2. And as we approach positive infinity, it also gets close to 2. All right, we'll look at example 10 and then we'll stop. So your homework looks just like these problems. Just like these problems. As x approaches 0 from the negative side, what happens to my function? Keeps getting smaller and smaller and smaller. So that's going to be negative infinity. As x approaches 0 from the positive, what is my function getting closer and closer and closer to here? Negative 1. We're getting closer and closer to here. The limit as x approaches 0. Is it the same from the right and left? No. No. So we say it does not exist. The limit does not exist. The function value at x equals 0. What's the function value at x equals 0? 1. They give us a dot at 1. So function at x equals 0 is 1. As x approaches negative infinity, as we get larger and larger and larger this way. This one I think is a little ambiguous. It looks like it could be 3. It looks like there could be a horizontal asymptote at 3. They don't have one drawn in. So if I gave you this problem and you said that the limit was 3, I would be okay with that. Well, because there's not a horizontal asymptote drawn in, you could also assume that this function keeps going up and up and up. So I think this question's a little ambiguous. So I would accept either 3 or positive infinity, because that asymptote's not drawn in. It looks like there should be one there, but we don't know for sure. I would accept either of those answers. And as x approaches infinity, as x approaches positive infinity, what happens to my function? It just keeps getting bigger and bigger. So that would be infinity. All right. Any questions on limits, finding limits using graphs? Yes, Cedric.
Can you explain 10C again?
10C. Our limit is different from the right and from the left. So our function, so the limit does not exist. So if we're looking at the limit as we're approaching a specific x value, they have to be the same from the right and left for the limit to exist. So that limit does not exist because we had negative infinity from the left and negative 1 from the right. Okay? All right, so your homework is the so I think what I did was I just did a good chunk of your homework problems. So look at number 11 and 12 that are left on your sheet, and then start looking over finding limits algebraically, and we'll talk about that after a quiz.
Wait,
So-
we're testing 11 and 12.
Yeah, because I thought that those were still examples, so I did 4 of your homework problems.
Wait, 11 and 12. Don't have to do
You don't have to do that, but just start looking over the information about that.
it like this.
Yeah, like that.
Alright, let's do these.
All right.